So the one that was left, I think number 4, it was not done. We were doing that inductor capacitor. You still remember? That was the last question which we did for number 3. So we were left with 4 and 5 for this
We
question.
didn't do 5. Didn't we do 5?
Hello?
Hello. Oh, I was asking that, didn't we do number 5?
Question number 4, we did not do it.
Yeah.
So let's do number 4.
Okay.
Then the recording, she'll get it when we are done.
Yeah.
Yes, let's finalize this question then. So the figure shows 2 masses, which means the first mass, 3 kilograms, 3M. It was not given. The units is just 3M. And then M is just a mass M hanging from springs with spring constants, 4S and S respectively, which means when they are saying 4S and S respectively, you know what it means, which means the mass for the 3M is corresponding to 4S. Spring constant, and this one is also corresponding to S respectively. So assume, yes, that's what they mean. Whenever they say the spring constants 4S and S respectively, it means in that order. So if I started with 3M and M, also the constants, they follow the same order, 4S and S. So which means 4S is corresponding to is a spring constant for the 3M mass, and S is the spring constant for the mass M block. Okay.
Mm.
Then we are given that assume the solutions of the form. So we have been given these solutions. So assume the solutions of the form x1. It's a e to the power I omega t. X2 is b e to the power I omega t. So these are the solutions which we are having, x1 and x2. The question now is saying find the angular frequency of the oscillation. Describe the 2 normal modes. And you can see how many marks there.
10 and 14.
Yes, it's a lot of marks. 14 is a lot. All right. So let's analyze that question so that we see what is it that we are expected of in that question. All right. So the 2 masses we know, M and 3M and M. So these are the 2 masses, 3M and M, which is corresponding to the spring constant 4S and S. All right. So let the displacements down from equilibrium be x1 of t. So which constants are they referring to? This one. From equilibrium position. So which means let the displacements downwards, the displacement downward from equilibrium position be x1 of t from the top mass 3M and x2 from the bottom mass M. So that displacement which we are referring to. So the displacement, remember x, when you are calculating the spring constant x, if you want to know the force in that spring, force is equals to k what?
Kx.
Where k is representing what?
Spring constant.
So if S is now representing the spring constant, How are you going to write it? It will be S what?
X.
Minus
Oh,
Kx
minus.
raised to force minus
Mm,
S Sx. Because the spring constant, you have been told that it's what? It's S, isn't it?
yeah.
So that is our starting force. And we use the same formulas which we told force is equals to mass times acceleration, where we are going to be putting displacement, that double dot, which I used to tell you that the double dot, it means acceleration. So this is
Displacement, velocity.
A.
Yeah.
It's one dot, velocity. Double dot, now it's acceleration, okay?
Yeah.
Right, so we must master these ones while we are doing this problem so that we are on the same page. So now we are going to label, so which means the first function which we are given the solution is the one that we are going to label as x1, and then the second one is x2. In the spring constants, we are having our spring constants K2. The spring constant 1 is 4s, spring constant K2 is just s. This is just. So between the masses, gravity is already accounted for in equilibrium length. So now we are coming now to the equation of motions. Just like the same way we've been doing that assignment. Here we said this is corresponding to K1, or which is S. Anyone that you would want to use, but if it's 4S, the spring constant, it will be K here, and it's corresponding to X of T, the displacement along this part. For the 3M, remember this is 3M. So this is 3M. And then this is the 2, the M.
The M.
So that S which they are referring to, this S, we said let the spring constant or the displacement from this mass be x2 of t. So in this region, we are going to say it's going to be x2 of t, the displacement, how far the spring is going to move, and then this one will be x1 of t. So these were the conditions that we said let. So let that function which we are given here be the displacement along this line. And x2 is the displacement for the second mass after the 3m mass block. So this is our setup for now. So now we want the equations. So how do we get the equations? From here, for the 3m mass block, remember we know force is equals to mass times what?
What?
Remember,
Acceleration. Oh,
force
FM. Yeah.
equals to
MA
mass
times
times what?
acceleration.
Times acceleration. All right. So we know for the 3m block, that's where the issue of the signs they come in now. Force is equals to mass times acceleration. So let's go to the mass, to the masses and the displacement, and the minus kx, where it's going to come from. And we know that force as well is equals to minus kx. But now we are being specific. We said the k, the spring constant for the first mass, it will be 1. And the displacement for the 3m block is going to be 1. All right, so let's check our diagram so that we are clear. So which means if I want the restoring force here, from Newton's second law, which says force is equals to mass times acceleration. If this block is hanging, which means the displacement is moving in this, according to this solution, which is A is equals to e to the power I omega t. So that is the displacement, how it's going to be defined at any time remember it's having t, which means the displacement at any given point in time, you can calculate it using this formula, x1. So now the force of the 3m block, it's attached to another force, which is m. It's not only hanging. There's this force, which is m here. So that is where the minus kx, when you are saying sum of all the forces, force, for it to be balanced, the restoring force, we are saying the minus kx minus k1 times the displacement for the 3 kilogram block plus, which means it will be now k spring constant k2 x2, like that. Then minus k2 and x1. Here they just factored out k2. But in order for you to understand the equation, you must know that F, force, is equals to mass times acceleration. So that force is equals to, we are saying it's equals to minus K1 X1 plus, this is positive. So I want you to check the direction of the forces. Which one is going in the opposite direction and which one?
I'm a bit confused there. You're saying that force equals to mass times acceleration, right? And then force is equals to spring constant multiplied by x, right? Now
Yes.
we are 3m. Use yeah, that part, 3m, and then the x dot, which is is it acceleration?
Yeah.
So this part of where you are saying you are equating it to k1 x1.
Or that's where you need a bit of clarity.
Mm.
All right, so let's do it like this. On a straight line, this can be represented by F. Do you agree? This is a force.
Yes.
3m multiplied by, it's a force, isn't it?
Yeah.
And also, spring constant multiplied by x is also a what?
A force.
Also a force. The negative part is just coming to say is the restoring force in the opposite direction. So it's also a force. All these which are forming, these are all forces which we are talking about. So for these forces, remember, we are dealing with what? Newton's second law. They are no longer stationary. These forces, they are making the object to be moving at any given point in time. That's why you are having an acceleration. They are not equilibrium forces now. All right. So in this case, what are we saying here? Check our diagram. On our diagram, we are having two mass blocks of 3m and m. All right. So first, if the 3m block is attached there, it's going to exert a force going downwards. I'm just talking of the 3m block, isn't it?
Yeah.
A force that is going in the what? In the negative direction, isn't it? Hello?
Hello. Yeah. I'm listening.
In the negative direction. Then the restoring force, it will restore that before it starts to oscillate, that spring, it will try to restore this block from its original point by restoring force, which means that's why it's in the negative direction. That's why we are saying these forces, they are the same, but in opposite direction. That is the only difference.
So in the negative
I'm
direction, it's coming So the
I'm
negative
only
direction.
referring to the force on the 3M block for now. I have not talked about the force on the M block yet.
Okay,
Only
why
the
is it
force.
going to an opposite direction? I want to understand that part. Is it
It's
because of the
a spring has weight. A spring, the mass block has weight. So when you put a weight on a spring,
Oh, it moves to an opposite direction.
its weight,
Oh.
it starts to oscillate back and forth. Remember, it's a spring.
Mm.
Like going up, coming down, going up, coming down
Yeah.
until a certain point. That's why we have a graph where it will be going up, coming down, going up, coming down, going up, until it's doing like this. Damping, the damping constant of the spring, remember.
Mm.
That's why at some given point in time, it's no longer oscillating. It will be just straight now. All right. So for the first part, only for the 3M block, we are saying the mass times acceleration. This is force. What is the mass times acceleration? The acceleration which we are having, the displacement of x1 dot double dot, that is ma. That x double dot here is representing
Mm.
ma. What is 3m? 3m is the mass itself. It's not
Mm.
3 times. 3m is just the mass as a whole. It's mass. Then x1, this is what we are referring to as the acceleration. So mass times acceleration, it's a force. So mass times acceleration of this block, of the 3M block, what does it give us when we are talking about the spring constant? The spring constant, it will say K1, which is the spring constant in that mass, which is attached to that mass block. But why is it a negative? It's a negative because it's the restoring force. But because there is a block that is attached again, there's a block which is attached to that spring, which means the force that is going downwards, which is the force which is resisting the motion of going up, is this one in the second spring. So which means here we are going to have a force that will try to restore the spring this side, which is the minus kx direction. But it's also attached to a mass block which is moving again, restoring at the opposite direction. That's why we are not adding x2 and k2. We are saying plus. It's because of the direction. It's a negative direction compared to the motion of the 3M block.
Mm.
That's why here it's a negative. The directions are not the same where I've put here. Here. For the first one, it's a negative K1,
Mm.
X1. But for when I'm dealing with K2, the spring constant, the force in the second spring constant, I've put a K2, a positive spring
Mm.
constant multiplied by X2. Why? Because the direction is not the same. Remember, when the 3M block goes up, when the 3M block goes up, the the M block is moving in the opposite direction
Okay.
because it's put down. It's a weight which is pulling down the motion of what? Of the 3M block. That is the idea why we are setting up our equation like this for now.
Mm.
Hello?
Is it because
Then
the M doesn't have the weight? It's just the mass. It doesn't have the weight.
it's because of what?
Is it pulling down because it's just an M? It doesn't have the weight like the 3M.
No, the
Is it?
3M is it's a mass. 3M is a mass.
Mm.
So that mass block is also being pulled again by another mass block, which is M. Yeah.
Mm.
It's not only one block which is just hanging. It's also having another mass which is pulling it down.
Okay.
Yes. Which is pulling it down.
So is it why you wrote the so you multiplied by you the second one you said positive K spring constant
Yes.
x t bracket x2 minus x1. So on that
Yes.
one you wrote negative because it's pulling the 3m is pulling on the opposite direction.
Yes.
Or it must always be negative.
Negative. Yes.
Oh, okay. No, I get that.
So if you fail to set up here, everything becomes wrong.
Mm.
So this is the important setup, which will make sure that everything that is going to come is correct. So once you have understood this one, everything that comes now is just mathematics. So setting up this equation is the major. Everything that is coming now, just maths. So the major important is how to set up this equation. When you are given a 3m mass block, which is also hanging attached to another suspended mass m, which is underneath. So 3m it's a mass on its own. M it's a
So
mass on
say so that equation you are basically explaining using that equation that the negative x1 is a 3m which is
yes,
attached and then it's moving in an opposite direction, but
yes,
at the bottom they say mass that is pulling it in
count,
also an opposite direction. Is it so?
yes,
That's why you wrote it as a positive. And then you also from the positive direction you wrote x2 minus x1 because they're also attached in the same string.
yes, that's correct.
Oh,
That's
so you're
correct.
explaining in that one equation everything.
Yes. So
Oh.
now it's substituting now our values, then we solve. So
Mm.
where there is our f, where we are having our f here, we replace with what? We say the f, that mass times acceleration, it's a force. So what
Mm.
was the mass for that first block is 3m. Then what was the acceleration? The acceleration, I'm going to differentiate x1 because I was told that the displacement along the first spring is given by x1 of t. We assumed here that let the displacement along the 3m block be x1 of t. So if I want the acceleration in this region, I differentiate this displacement how many times? Twice.
Twice, yeah.
If acceleration. So if I differentiate first time with respect to t, just like that question which we did the other day when we were differentiating this, then you put it back into the equation. You differentiate
Yeah,
the first time, you differentiate the second time, you plug it back. That's what we are doing. And we are
I remember
differentiating
it.
with
Mm.
respect to t. T. So if I'm to ask you what is x1 dot, what would be x1 dot with respect
Velocity.
to the velocity? What is it? Here there is I omega t. This is I omega t. So if I differentiate with respect to t, I'm going to get what?
You're going to get
I, I'm going to get
I W
I omega
A
a,
E
yes, to
and
the power,
then negative IWT.
not negative, but what? Positive.
Really?
IWT, positive. Why is this supposed to be a negative? When you differentiate an exponent, it comes back as it is. But
Oh, I
it's
I
an
mean, yeah,
exponent.
it's an exponent, man. I thought you were going to say -1. Yo.
The minus one will come on the second part now, the one which you are talking about. When we say x double what?
Double dot.
One. That's when you get the minus one, which is going to say I times what? I times
W
I, then W times what?
W
Which gives you W what?
squared.
And already A is already there. So A, E to the power I omega what? T. So that is the first point. Yeah. So we take that x1 double dot. So if you are to simplify this, you get I times I, it's negative, isn't it? Yes, root of -1 times root of negative is negative. So it will be negative omega squared. A e to the power I omega.
Oh,
Yes.
yeah. Oh, I times I. Yeah. No.
I is just what? Square root of -1 multiplied by square root of negative.
Negative one. No, I remember it now as you were writing negative. Oh, Hashem. I need to practice. I'm
Practice. Because these are some concepts of physics which you must get used to.
just
So one
slow.
I times I, -1, square root of,
Mm.
negative. So from here, that's what we did. So which means we are having here what just happened. We factorized. Remember, you see K2 is common here. Then this was just factorization. We factored out. That's they did. So they grouped K2, X2 minus X1. X2 minus X1. All right. Then in terms of S, we are now talking in terms of what? Of S, isn't it? This was just our string constants. So now in terms of S, remember we're given S.
And
So
for
yes, where there is what?
where there is K1, we put 4x.
We just they just rearrange the
Where
X1.
there
All
M3,
values are having X1, you group them together. And all values which are having X what?
2.
X2, they are just standing alone. So you find out this bracket, it will be broken down. Then you come back to the original that we were having already. Then you just group the bracket, taking out the negative outside. It will be K1. Let me do it for you so that you see proper. Remember our standard equation, which is there, this one. So we are just grouping there. That's what I'm saying. You are going to say F is equals to, you factor out all the things that are having what? You factor out everything that is
with K1.
having, yes. So which means everything that is having X1 and everything that is having what? X2. So if I factor out negative X1, for example, this one, or before, let me group the things which I want. Let me group the things which I want. So it's negative K1, X1, like this. Minus this minus. That's what I'm referring. Minus K,
K2x1
X1. Then you do the same plus what? K2
plus K2
X
2.
X2. Then from there, you just come and say F is equals to, you factor out the negative. So it will be minus
K1
X1 minus
x1
X1 bracket K what?
1
K1 plus K what?
2
K2. Then that one is just the same as plus what?
x2.
X2. So whether the negative X1 sits on the front or it sits here in front, it does not matter. It does not change the value. Yes. So because in our question we're given in terms of S, now we are just doing the same. You are replacing your standard units that you were given in the question. That to say F, this force, where there is X1, remember K1, it stays the same. Where you are just changing the constant. The constant which was corresponding to the 3M mass block was said it's forward, 4S.
4s,
So
yeah.
where there's K, now we are just replacing minus x1 bracket 4s plus s, like that.
Is, yeah, for M.
Why are we replacing? So that we can able to add them since they are related. Then you
Yeah.
say plus. Where there is K2, now we are representing,
S.
so it will be S x2.
X. Mm.
Then from there, we are having the same similar equation. Add like terms together, 4s plus s, what do you get? 5.
5S.
Then this one is standing on its own. So now we are having a differential equation for the 3m block, where
Mm.
3 multiplied times 3 times acceleration, 3m times that acceleration, x1. It gives you that equation in terms of s. So now we do the same for the second mass block. Let's go to the second mass block. We see what is happening on the second mass block. The forces. If this force is going downwards for the 3m block, if it goes downwards, which means the force is equals to negative k what? K2
K2.
x what?
X.
X2. Yes. But there is another force that is resisting the motion of that block. You need to compensate it as well. You need to compensate that force, which is positive K2 x1 due to the spring constant of x1. That is the only force that is resisting the motion of the restoring force. Which one? It's this one. So here we are subtracting. Since this is and going in the restoring force, so here it will be plus. Plus what? K what?
K1. K2.
The spring constant, which we are having here, the displacement, which spring constant is moving? Which spring constant are we compensating is going upwards for the second one?
It's M.
K2, x what? X1. Can you see? Hello?
Yellow. So the MX, the displacement on the second one, X1.
Yes. This K2 is representing the what? The M block.
Yes.
K2, the M block. Then X1, the displacement going upwards. Remember, we are saying the force on this block. Remember, the force on this block. For it to be balanced, there is a force which is going downwards for the
Yeah.
mass of the block. Therefore, the restoring force, it will go upwards. So if this force which is going downwards is a negative force, which we are saying negative force, which is negative K2, this one, negative K2, X2, multiplied by X2. And upward, there is a spring which is attached here. Remember,
Mm.
there's a spring that is attached there. The direction plus opposite direction, you do the same.
Mm.
Just like what we did the first, opposing that motion of the restoring force. That's why this negative and negative, it's a what? The positive.
Oh, the X is just for the direction.
The X is, we are having K2, which is the spring constant here. Then X is the displacement. How far did that spring move? The one which you are referring to, that it went up, it's opposing the motion upwards. it moved for what displacement. So we are using this spring, the displacement which we are using there, it's x1. K2 multiplied by x1. So here we are not going to, on this mass block, we are not going to use any K1 on the last block, which is hanging alone. The
But
first
because it
block,
doesn't affect the movement.
no, it does not. Yes, it does not.
Oh.
There's nothing dragging down. Yes. So there's nothing. So we are not going to include K1.
Mm.
But on top, we included K2. Remember? We
Yeah.
included K because K2 was pulling what? Down.
Yeah.
Mm. All right. So now when you set up that equation, which means this, it can be written like this, which means I can also write it like this. Mass times acceleration for the second block, which is double dot, is equals to negative K2x2, which means we are referring to the second constant, spring constant, using the second displacement, plus K2 and multiplied by the displacement of x1, which is pulling upwards. The movement, it moved up. It also moved upwards. By how many? What was the displacement of x1? Then from there, you do like what we did on top. You are now substituting where there is what? K2, you replace with the S.
Mm.
K2, you are replacing with X. SS. There is no K1, so you can't replace with 4S.
Mm.
Replace with S. Now we have our differential equations, the solutions, which was x1 and x2. Now you replace this equation that we got. Remember, we said on the first one, it was 5s, negative 5s, x1, this one, which I'm reading here.
Yeah.
This, yes. Negative 5s, x1
Plus
plus s,
this.
x2.
Mm.
What is x1 and what is x2? Yeah. So we are equating all of them to
Yeah.
0. Yes. X1, x2, x1, x2. We equate them to 0. Why are we equating them to 0? Spring constants, K1 was given 4S, and then this one we did that one. And then this is our differential equation. We are done with this one. Now we are solving for omega. So letting y equals to omega squared. So the reason why we are going to end up with that, you still remember that quadratic equation when you're having omega 1, omega 2. Yeah. Omega 1, omega 2. Do you still remember that time when you used to solve for omega? When
Mm.
you're using the quadratic formula, that is
So
where
there's
we
something that I don't understand there. Where now you are done with the equation, where you are replacing just below the x1 equals 2 and the x2, just below that. I saw you wrote 3m and then the other one you wrote m. No,
yeah.
yeah, just move a bit down. Yes, there where you are going to equate it. So there, the equation said 5s minus what was it, x1. So now, are you using that equation where you differentiated there, where you
Yes.
differentiated in terms of t, you differentiate twice? Are you using it there?
Yes. Here, isn't it? We are using mass times acceleration,
Mm.
the one that has been differentiated. Yes.
In terms of t.
Yes.
Oh.
Yes. Because we are saying this is the same value as this. Can you see? Right.
Yes.
Let it clearly and neatly so that you can see from a lot of stuff.
Mm.
All right, like this. What we are saying here from the equation which we are having here, you can come and say mass times acceleration double dot is equals to minus s x2 plus s x what? X1, which is equals to what? What is s x2? What is our x2 here? X2 is b e to the power what? Omega.
IWT.
Yes, this one. That is our x2. So if you come and substitute it into that equation, where you are saying it's minus x2, it will be, you are having an s outside, isn't it?
Mm-hmm.
And then you are having what?
A B which is constant, yeah. BE.
E I omega what?
T.
Omega t. And then you are also having a what?
A plus
An
S
x, which is
X1.
x1. So which means there I'm going to put a plus what?
Plus
What?
S
Which is
A
a
E.
e to the power. But there's
Are you
an
not supposed to write S?
we need to put an s. So first there should be an s. So there
Yeah.
should be an s first. So let's put our s. So it will be s a e to the power what? I
WT.
omega t.
Mm.
All right. Are you seeing everything now? So we are trying to push it here. This,
Mm.
okay. We are having s a, and we are also having. So where did the other constant disappear to? If I'm to ask you, where did the other constant disappear to? If I'm to,
Because there you replaced the way it was. I think you differentiated twice, if I'm not mistaken.
where did you differentiate once?
The the BE to the power
To say
I omega T. Yeah, that one.
between this one and this one, what is happening here? Hmm.
That was my question. That's what I want to understand. I think you differentiate twice.
Which one did you differentiate twice?
The negative S B E to the power I omega T and then plus S A E I to the power I omega T. I think you differentiate it. I'm not sure, but something was done. Yo,
All right. So let's check it if we differentiate it, because there is a step that we, after that step, there is a step that we did not, yeah, here, where we are saying x1 is given by this,
mm,
x2 is given by that. Then remember, my mass, if I'm substituting into that first equation, which I'm having mass times acceleration. Mass times acceleration. Which one am I talking about? This one. This. Minus 5s x1 plus S x2. So if we are equating to 0, if you are equating this to 0, which means you brought the other ones to the other side. Which ones did you bring to the other side? If you are equating to 0, if this is going to be equals to 0, which means this must come this other one. Means
Okay.
it has to be 0. So if I'm going to equate to 0, I am not only going to have this on the right, but it will be also the same as minus 5 s x1 plus s x2 minus what? 3m
M
multiplied by what?
X dot W dot 1.
Then now it's equals to what? To 0, which is this one, this equation which I have. So this equation which I having, it's a simplified equation for the first differential equation, which is corresponding to the 3m block. So this one is another equation which is corresponding to the what? M block. Only for equals to 0. So now up to here, are you able to find it your way from here up to here? Are you able to come from this side to reach there where there is the 0 on the other side?
Hi.
You can't?
Mm-mm.
Why?
Mm.
What will be the problem? When you differentiate the second derivative, we said, what is it that we are going to get?
Oh yeah, is the
When you differentiate twice, you are going to get negative, isn't it? Negative omega what? Squared.
omega squared.
Yes, that is it. So this is coming from there. 0 is equals to negative 5 what? S x1 plus s x2 minus 3m. X1, you differentiated it twice. So if you differentiate it twice, remember it's going to give you negative omega what? It will give you negative omega what?
Omega squared.
Multiplied by what? A, isn't it?
A E. Yeah.
So which means here x, which means it's going to give you multiplied by negative omega squared.
What happened to the E?
The E, they are appearing on both values. On the
Oh.
left, on x1, there is e to the power of omega. And then on x2, even when we differentiate, we are getting e. So if we are solving, when you divide by e both sides, it disappears.
Yeah.
Yes. When you divide by e on the left, 0 divided by e, it gives you 0. Then on the right, you cancel all the what? The e. Then they vanish. E to the power I omega t, it goes. So let's check where we are and what is it that we are having. Is it similar now? Let's check minus 5. And then the b. We still don't have a b yet. Where is x2? Yes, x2 is here. X2 is there. That's the b. And the b is sitting alone. The b is sitting alone. All right. And then 5s minus 3m omega. So check now how the signs they change so that you understand. This is 0 is equals to negative 5. So this is negative 5 s. So if I am to multiply each and every term by a negative, what are you going to get? This equation, you multiply the
Positive.
right, by a negative. You are going to get here it will be a positive what? 5s. Can you see? If 5s x1. You multiply by a negative minus s what? S x2. But remember, this is negative times what? Negative. It gives you a what? A positive. You are multiplying these two. They give you a positive. Negative times negative, it's a positive. So positive multiplied by again a negative. That's where the minus is coming from. So it's minus 3m a omega squared. That's where it's coming from. Multiply by.
Too much information, sir.
No, this one is just the measurement. We are done with the derivation. We just want to show you the relationship here only, this equation. But the mathematics, we are done with the math part. So the 5s, where I want to show you the 5s here, minus the 3m omega there, and x1. In x1, that's where a is contained. So I will replace x1 with a e power omega what?
T.
Divided everything. Where there's a s x2, I'm replacing x2 with b because that's x2 contains b. The omega e to the power I omega t has been cancelled after I divide. So you group the a's together. 0 is equals to 5s. You take that one minus 3m omega squared. You close bracket. Everything they are sharing a common word. A minus s multiplied by b. So it's a matter of just putting those two equations so that you equate them to 0. So I've shown you the first one, how they got the 0. You do the same on the second one. That's what is happening. Then from there, once you have your equations in terms of 0, which means this one is equals to 0, and the second equation as well is equals to 0. How do you combine those two equations? How do you combine those two equations? If, let's suppose this is equals to 0, and also this one is also equals to 0. So now you want to calculate or to solve for the common, or you find the quadratic equation that you want to solve for omega. So using the common factors, things which are common, which means if this bracket is equals to 0 and that, which means in other words, this bracket, s minus m omega squared, this is the one, minus s squared. The first bracket is this one. Are we there?
So you take out the A and the B's outside.
Yes. Then what are you left with? Eh? Are you lost?
I'm lost.
Check
So
check the constants a and b, which are having a and b. You are multiplying the brackets. A and b, those brackets. So which means a, this bracket, a and b, it vanishes. A and b are gone. Then what I'm left with are these two brackets. You do the same. Minus sb and minus s.
S A.
So which means s squared, s times s, which is s squared. When you expand, now it's a matter of us solving for the omega when you expand everything that is. But how did you get rid of everything, those two equations to come to here? You take the expressions that are having a constant a and b, you multiply those brackets together. Then the
So when we multiply negative SB and SA, are we not supposed to have positive S squared?
no, we are not multiplying. Remember, it's plus. We are adding those two. Remember, so it's a plus minus. So a plus minus give you what? Hello,
A minus.
it's a minus. Yes. The plus, if this one was positive, positive here, this positive, positive, we are going to have a positive here. But in our case, there is no positive, there is a negative, negative. So what you are simply multiplying, it's not the sign. You are multiplying the constants here, s and s, taking the sign as it is. Can you see the sign for the a and b? It's positive. This is positive. This one is also positive. That's why here it was also what? Positive. So the signs, they are coming as they are. What you are only vanishing, the vanishing things are A and A, B and B. They are vanishing there. Then you are left with only the constants are gone. You have eliminated the what? The constants. Do you know how to eliminate constants? These ones are just simultaneous equations.
Maybe that's my struggle. If I could just practice on that one.
My problem, you guys, you don't even look at these things. You just see them while I'm teaching you now. That's why sometimes tough for you. Is the pressure too much that you are not having time to just browse nyana the nose?
No, we will. I will, Shem. I'll start preparing. It's just that it
Mm.
was a lot, but I'll try. I'm trying to finish all my assignment this week so
Let's
that we
stop
can
here. Then
start.
solve for omega tomorrow. Let's stop here. Then we'll finish the omega tomorrow.
Yeah,
I'm
I'm
talking
no
alone.
longer understanding now. Yeah.
Let's stop here. But the other ones, I think you have a clue for
Mm.
finding. Yes. What is left is just here.
That's why
So
it's 10 marks. They saw you are going to work. Hey.
yes, there is work, but we are almost getting done. So tomorrow we'll start from solving the omega, then we find the solutions.
Mm.
These questions is there in every exam. We must know how to deal.
That's the thing. Yo.
Know how to deal with it. All right, let's stop here for now.
Okay. Bye.